Part A. On the same axes, sketch the graphs of the curves with the equation y equals x squared times x minus 2 and y equals x times 6 minus x. So let me draw a set of axes here. There's my x-axis. Here's my y-axis. Right, in blue, we'll draw this cubic. So looking at this, I can see that it will intercept on the x-axis at 0, and that's going to be a repeated root because of the squared there. I can see that it's also going to intercept at plus 2. Actually, let me just rescale that. We'll say 2's there. It's going to intercept on the y-axis at 0 as well. If I were to expand this out, I would get a positive x cubed. I'd get x cubed minus 2x squared. So it's a positive x cubed, so it's telling me that it's going to start by going up like that, rather than if it was negative like that. So my graph is going to look something like this. It comes up to where there's a repeated root. So it's just going to touch at the repeated root where it's squared from here. And then it's going to go back up through to there. So that's the cubic. Now let's draw the quadratic here in red. So again, I can see that's going to cross-intercept at the origin there. And I can see it's also going to intercept on the x-axis at 6. If I were to expand this out, I'd get 6x minus x squared. And that minus tells me it's going to be a N shape rather than a U shape. So let me draw my N shape. It's going to look something like this. There we go. One thing to point out here, it's important that you show that the two graphs will intersect at this point down here. If I had drawn my graph like this, that would be wrong. And the reason why that would be wrong is because the blue line is an x cubed. The red line is an x squared. And the x cubed, because it has a higher power, will always become bigger than the x squared eventually, when x becomes large enough. So at small values of x, maybe not, but certainly as x becomes bigger, the blue line will always overtake the red line. The cubic will always overtake the quadratic. So I have drawn both of those curves. I need to indicate on the sketches the coordinates of all points where it crosses the x-axis. I've put the 2 and the 6 on there. The 0 is kind of implied, but I'll put the 0 on there as well, just to be absolutely clear. Right, part B. Use algebra to find the coordinates of the points where the graphs intersect. Right, so intersecting, we're thinking about simultaneous equations. So that's going to be when x squared times x minus 2 equals x times 6 minus x. So we're making those two y coordinates equal to one another. Let's expand the brackets out. And we're now going to add x squared to both sides. And we're now going to subtract the x from both sides. Sorry, subtract the 6x from both sides. To solve this, it does say to use algebra, so you can't be using any calculator methods here. We're going to factorise the x outside first here, because each of these terms has an x in them. And we can now factorise that quadratic to be it's going to be an x minus 3 and an x plus 2, I think, because the minus 3 times the 2 is minus 6. The minus 3 plus the 2 is minus 1. And now we can see that if x equals 0, or x equals 3, or x equals minus 2 are all points where these graphs intersect. We can now find the y-coordinates by substituting these x-coordinates into either of these original curves. It doesn't matter which you substitute in. So I'm going to substitute them into the quadratic, just because I think it's a little bit easier. So 0, if I substitute 0 in there, 0 times 6 minus 0 is obviously 0. Substituting 3 in, I get 3 times 6 minus 3, which is 9. And then finally substituting the minus 2 in, we'll get minus 2 times 6 minus minus 2, which is minus 16. So we have the coordinates 0, 0, 3, 9, and minus 2, minus 16, which, comparing those to the graphs, hopefully makes sense. 0, 0. We can see that the graphs intersect at that point there. We've got the point 3, 9. That's this coordinate here where they're intersecting. And like I was saying a few moments ago, this we've also got this minus 2, minus 16, which is this point down here, which like I said earlier, our graph needs to show they intersect down there.